In the beginning, our entire universe was compressed within the confines of an atomic nucleus called the singularity, before creation, when space and time did not exist. Then an unimaginable cosmic explosion hurled matter in every direction and created the beginnings of our universe, matter and energy, space and time itself. Moments after the explosion, the four forces of nature, strong nuclear, weak nuclear, electromagnetic and gravitational forces, combined as a single superforce, the Wald. For each billion pairs of heavy particles, hadrons, that were created, one was spared annihilation in particle-antiparticle collisions. During this creation and annihilation of particles, the universe was expanding at many times the speed of light. In the time known as the inflationary epoch, the universe doubled in size at least 100 times in less than 1,000th of a second. At this point, the universe was an ionized plasma where matter and radiation were inseparable. When the universe aged to 100th of a second, old neutrons began to decay on a massive scale. This allowed for free electrons and protons to combine with other particles. The formation of matter from energy was made possible by photons materializing into baryons and antibaryons, with their subsequent annihilations transforming into pure energy. Because of these collisions and annihilations, matter was unable to remain viable for more than a few nanoseconds before a bombardment of electrons would scatter these photons. Radiation was so dense that no light was visible. In this epoch of last scattering, the temperature had dropped to the degree that the strong nuclear, weak nuclear, and electromagnetic interactions were now able to exert their force. As the gas cloud expanded and the temperature of our universe had dropped to 10 billion degrees, photons no longer had the energy to disrupt the creation of matter, as well as to transform energy into matter. After 3 minutes and a further drop in temperature to 1 billion degrees, protons and neutrons slowed down enough to allow nucleosynthesis to take place. Atomic nuclei of helium was produced, and 2 protons and neutrons bonded.